Alright everybody, so what we're going to take a look at here, is how to graph these exponential growth functions, okay? So we're going to take a look at these and see what's going on, okay? So sketch a graph of the following functions without the use of a calculator and complete the blanks. So I'm going to be giving you guys these blanks down here, and I want you to fill them in to the best of your ability, okay? Now one thing that, based off of yesterday, I need you guys to keep consideration. Your horizontal asymptote will always be y equals 0 unless there's something that's like tacked on the end, like a plus or a minus on the end. Unless something on the end of your function. And you'll see what I mean by that in just a few minutes, okay? So, what we've got here first, okay, is we have y equals 2 to the x. So what we're always going to do here, and it's pretty much spelled out for you guys, you're going to plug 0 in first for it. So 2 raised to the 0 power, anything raised to 0 power is 1. Please don't say 0, but now you guys should know it's 1. Okay? I got to pick another point. I'm going to pick 1, comma. If I plug a 1 in here, 2 to the first is just 2. Okay? Do you see any plus or minus at the back end of this? No. So therefore I know my horizontal asymptote is y equals 0. Well, let's go ahead and get us a sketch. The asymptote, I'd like you guys to label as a dashed line. Now, granted, if it's on the x-axis like it is right here, it's kind of hard to do that. Here are my points: 0, 1, 1, 2. Okay? And what you need to be looking at is it gets closer and closer to that horizontal asymptote, and then it rises up. Okay? We're asking you guys for 2 points. It should never really touch there. I apologize, my human error. I know you guys probably think I'm perfect, and you're probably close to right. But that's a bad joke. But it's rising up. It should never actually touch there. Now, as far as your domain goes, how far left is this going? Negative infinity. How far right is this going? Positive infinity. So my domain is just negative infinity, positive infinity. Okay, range. Starting low, going high. Where does my graph get close to? The line y equals 0, but never actually touches it. So I'm going to use a parentheses. And it goes up to infinity. That's it. See how simple that is? Super easy. You don't even need a calculator. Okay? Alright. Now, number 2. Y equals negative 2 to the x. Now the negative's chilling out front, so I'm going to raise my power to x first and then go from there. So my y-intercept, if I plug a 0 in, okay, it's 2 raised to 0, which is 1, and then I got the negative out there, it's negative 1. Here's another point. If I put a 1 up here, it's the same idea as over here, except instead of just 2, it's negative 2. Okay, 2 to the first is 2, the negative out there makes a negative 2. Alright, do you see anything tacked on the end? No, so my y equals 0. Okay, 0, negative 1. 1, negative 2. So, you should be seeing something very similar. Okay. What's the difference between these two graphs? It's reflecting about what? The x-axis. Okay. That should be an x or y. No, it's weird. So because of that negative, it's reflecting over it, which you guys have seen before with your parabolas, so on and so forth. My domain remains the same. Now my range, this is the weird one. You start low. It's going to negative infinity all the way down here. That's where it's starting at. As I come up, it's getting closer and closer to 0. So I do 0 with the parentheses. Okay? Awesome. Okay, number 3. Y equals 4 raised to the x minus 3. Alrighty. Now, let's take a look. Do you see anything tacked on the end here? No, so my horizontal asymptote is still y equals 0. If I plug a 0 in, this one's going to make you think a little bit, okay? 0 minus 3 is negative 3. 4 raised to negative 3 power. What that really is you're flipping it, 1 over 4 to the third, and 4 to the third is 64. So it's 1 over 64. which is very, 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 very tiny decimal. Keep that in mind. Alright, now, you know how I said pick another number like 1 comma something or a number that's nice? If I pick 1 here, I'm still dealing with a crazy decimal. So instead of picking 1, I'm going to pick, how about 4? Now why in the world would I pick 4? Because what's 4 minus 3? 1. What's 4 raised to the first power? 4. Isn't that a pretty number, like 4 comma 4? It's just nice to work with. So check out this graph. I know my horizontal asymptote is still here. Okay. 0 comma 1/64, which is way down here. And then 4 comma 4. 1, 2, 3, 4, 2, 3, 4. So as I'm going from left to right, okay, you can see I'm jumping up rather quickly, going this way. Okay. Now in my domain, I'm hoping you guys are noticing a common trend here. Negative infinity to positive infinity. And my range, I know, mine's blown, starting at 0, going to infinity. Okay. Just continue to keep working on domain and range. I can't stress this enough how much you're going to see this in the future. It's just, you know, one of those things that, like, you know, you look at it, you can't stand it, you're thinking to yourself, why am I going to learn this? But it's going to keep coming up more and more and more, so just be aware. All right. Number 4. Now, hey, what's this? Remember I was asking you guys what's tacked on the end? What is tacked on the end here? -3. So if you had to take a guess at what your horizontal asymptote is, we would say y equals not 0, but y equals -3. Ta-da! Cool. Now, if I plug a 0 in up top, check out what I get. 0 plus 1 is 1. 2 to the first is 2. 2 minus 3 is -1. Okay? Just a little bit of mental math there, guys. I'm not losing you on that. Now, I got to pick another point. I'm going to pick 1 because it actually works out kind of nice here. 1 plus 1 is 2. What's 2 squared? 4. What's 4 minus 3? 1. Cool. Alright. My first goal, especially now that I have a different horizontal asymptote, is to plot this line. Horizontal asymptote is what kind of a line? What kind of line could it possibly be? I have no idea what kind of line it could possibly be. Ooh, tornado. I always loved doing that as a kid. Y equals -3. So, dashed line across it, y equals -3. This is when you really want to have a dashed line. I know on the x-axis, kind of like, Here's my points. 0 comma -1. 0 comma -1. 1 comma 1. Okay? So, it's pretty much always the same sketch. Going from left to right, goes through my 2 points. Make sure you have your arrows on it. I'm hoping you guys are noticing it's always the same sketch, unless there's a negative out front and then you're just flipping across your x-axis. But it should be growing as it goes to the right, hence exponential growth. Okay, so this looks beautiful. My domain, oh my gosh, what can my domain ever possibly be? Negative infinity to positive infinity. You're going to be seeing this quite a lot. Now, my range, don't overthink this. Bottom to top, where is it getting close to? Y equals -3. It's going all the way up to positive infinity. Okay? So, excellent. I'm going to do one more with you guys, and then I'm going to let you guys try out 6, and then try out the homework ones on your own. Okay? Again, I really want you guys to try and do these without the use of a calculator. I'm not 100% sure how the test is going to look just yet, but I think you guys can do some mental math on your own. It's good for you. Alrighty? Here we go. Number 5. Do I have anything tacked on the end? Yes, indeedy. So y equals 2. See how easy that was? Now if I plug a 0 in, 3 raised to the 0 minus 4 plus 2. 3 raised to the -4 is basically 1 over 3 to the 4th. Okay, plus 2. 3 to 1 over 4th is 1 over 81 plus 2. Okay. So we're going to say roughly 2.01 or something. I'm totally guessing this right now, the decimal. 1/81. Yeah, I'm using this off to the side. It's 0.01. I was right. Yeah, that's awesome. Okay. So 0.2.01. If you guys want to just guess there, just assume that 1/81 is a really, really tiny decimal. I'm cool with that. Okay, I don't need the exact number if I give you a problem like that. Other point. Now, again, pick something nice. Okay, I'm going to pick 5. Again, why would I pick 5? Because 5 minus 4 is 1. 3 to the first is just 3, plus 2 is 5. Convenient. That's a nice point. Okay, so let's see here. 2.01. So it's roughly just over 2 for that. What's my horizontal asymptote? Y equals 2. Okay. What's my other point? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So again, notice the same kind of curve we got going on here. Starts to rise up. Okay. I got my curve, I got my arrows on the end of it, which I really want you guys to focus on. Your domain, never going to guess this in a million years. Negative infinity to positive infinity. Alright, and my range, look at where it's starting. Okay, it's starting at 2.01 like we called, which again, I know I said without a calculator, but you could literally put down this if you really wanted to. 2 and, what did I say, 1/81. You could put that down. You could put, if you really want to, I can turn this into an improper fraction. 162, 163/2, common infinity. If it makes you happy, then it can't be that bad, right? Oh, wait, sorry. It should be over 81. Butchered that, didn't I? Cover your eyes for a second, guys. Cool, good. Okay. But yeah, so I mean, if I asked you to do it without a calculator, chances are if I asked you to do it without a calculator, I'm going to give you one that's decent, okay? Because 1/81 is kind of a rough decimal. If you really want to also, I could just take a couple seconds and do long division, and I'd be alright, so that works. Yeah, we're looking good, guys. So, okay, I'm hoping that this video shows you it's basically the same thing over every single time. Figure out what your y-intercept is, or horizontal asymptote, rather. Boom, boom. Okay, roll from there, plot everything out. Most likely, if a quiz or test goes on this stuff, I'd give you all this junk right here. Okay, and then you just fill in the blanks. So, I'm hoping you guys are finding some cool applications of this stuff. There is actually a lot of neat things that goes along with exponential growth. So, keep up the good work. And as always, good luck. We're all counting on you.